So here is the algorithm, folks. You take a cell or a tissue, it's like epidermis, hepatocyte, platelet, fibroblast, and you add to it the word growth factor. And then you get your acronym, because medicine is really a study of acronyms, isn't it? Growth factors of the epidermis would be called epidermal growth factor. There's a family of transforming growth factors working on several types of cells called TGF. Hepatocyte growth factor is HGF. Vascular endothelial and fibroblastic growth factor, most important in neovascularization, VEGF and FGF respectively. I think you kind of get the pattern of what we're talking about. And do you have to know what each one of these things does? Of course you do, and that's why we're going to have to go through it. Well, you already know that they are polypeptides, and they're produced by a variety of cells, and they have specific targets. And they are the critical factors in cell differentiation and growth, and many, if not most of them, can be made by genetic engineering. And that's really nice, because this represents a marvelous future in medical pharmacology. Let's talk about the players in this role, in this movie. Many of them are from lymphocytes, and we have already said that if polypeptides are expressed from lymphocytes or macrophages and they're involved in cell differentiation, we define those as cytokines, didn't we? They can also be made by platelets or have platelets as a target, endothelial cells or endothelial cells as a target, fibroblasts or fibroblasts as a target, and so on and so forth. Keratinocytes, the epithelial cells of the skin, connective tissue or mesenchymal cells. And sometimes it's named, or usually it's named after the cell it acts on, and sometimes it's named after the cell it comes from. And because there's a wide variety of them that were discovered, sometimes there'll be alphas, betas, 1s, 2s. And you could guess there's a gazillion of them. Let's talk about the first one, epidermal growth factor, made in platelets and macrophages, or by platelets and macrophages, to cause epidermal, or basically keratinocytes in the skin, to migrate and divide. They also act on fibroblasts to produce granulation tissue. So even though we called it epidermal growth factor, because that's how it was discovered first, it can also act on non-epidermal or mesenchymal or stromal cells called fibroblasts to proliferate as well. Transforming growth factor, there's an alpha and there's a beta, and they're not really too well related to each other. The primary one, transforming growth factor alpha, is made by macrophages and T cells and keratinocytes. And what does it do? It does pretty much what EGF does, and it also has an effect on hepatocytes as well. There is hepatocyte growth factor, however, which has a direct effect on hepatocytes, but it was also discovered epithelium. And it's made in mesenchymal cells, which mean connective tissue cells, not epithelial cells. So here's a case like we see in embryology, where the connective tissue is producing substances to differentiate the epithelial-like tissues. Hepatocyte growth factor, HGF, also has an effect on cell motility. Here is probably the single most important growth factor, called vascular endothelial growth factor. And as you could guess, the VE stands for the cell that it is targeting to rather than where it's made. It's made by general mesenchymal cells, and it has as its target other types of mesenchymal cells called endothelial cell precursors, which is the key substance in showing the granulation tissue or ingrowth of new blood vessels following inflammation and in this mysterious process we call healing. Platelet-derived growth factor, no doubt, it's derived from platelets. It's chemotactic for many cells. It causes fibroblasts to divide. and therefore it is also a key player in angiogenesis and granulation tissue, or what we call organizing inflammation. Here's fibroblast growth factor. This one happened to be a question on the boards last year. Why? I don't know. But it's made by many type of cells and has fibroblasts as its target. But as you might guess, there are some non-connective tissue cells called keratinocytes, which it also has an effect on. And like VEGF, FGF, and VEGF are the key players in wound contraction and angiogenesis. Here's transforming growth factor beta as opposed to alpha. It's made by many cells, and the beta transforming growth factor is chemotactic for polys, or PMNs, or neutrophils, and many other types of cells. So in that sense, could this cytokine also be regarded as a chemokine? Probably could. Keratinocyte growth factor, no surprise. Another growth factor made by connective tissue cells, fibroblasts, and stimulates keratinocytes to migrate. So there's a locomotion factor there, isn't there? Proliferate and differentiate. So we constantly see these interrelationships between stromal or mesodermal derived cells and epithelial or ecto and endodermal derived cells. And it's pretty much what we knew from embryology. The stroma stimulates the epithelium and vice versa. Let's take a couple of other last ones here. Let's talk about the insulin-like growth factor. It's made in macrophages, fibroblasts. It stimulates a lot of extracellular matrix production, like the sulfated proteoglycans, but also collagen, keratinocytes, and fibroblasts. So with it stimulating all those different types of cells, you would think it would be an action very similar to our old friend HGH, or pituitary growth hormone. And in reality, it has a very similar action. So if that's how you want to remember it, go right ahead. Let's talk about tumor necrosis factor, one of the most widely studied cytokines or growth factors, if you want. In this case, it's made by macrophages, and it also activates macrophages. So this is autocrine, isn't it? And it has a key controlling influence on other cytokines. So very often when they talk about a process which is controlling the other cytokines, they'll always list TNF, especially TNF alpha, as well as the interleukins at the top of the list, because those two guys are not only one of the prime ones, but they are the prime controllers of other ones as well. And as long as we open the door, let's talk about interleukins. Interleukins are made in macrophages and a wide variety of other cells. And what do? Well, they're involved with chemotaxis as well. So could interleukins be called a chemokine? Yes, they could. They are also involved in angiogenesis. And like we said, with TNF, the interleukins, especially interleukin-1, is a prime regulator of other cytokines. So we're finished with the group here, and we're almost going to close off. But if there's only one thing you could remember as being the prime action of growth factors, it's angiogenesis, isn't it? And we'll start out the next chapter with talking about interferons. And thank you very much.